Hi, this is your instructor from an academy. Today we are going to explain how does an engine work. So let's get into it. Okay, so first off, what is an engine? Well, simply put, an engine is a machine that converts one form of energy into another. For example, in a car engine, chemical energy stored in gasoline is converted into mechanical energy that can be used to power the wheels. You have a chamber where you mix air with fuel and then ignite it. This explosion causes a rapid increase in pressure and temperature, which generates a force that pushes the piston. Now, there are several key components that work together to make this process possible. It's connected to the crankshaft by a connecting rod, and as the piston moves up and down, it rotates the crankshaft, which ultimately generates power. Now, the cylinder is simply the chamber where the magic happens. It's the space where the piston moves up and down and where the fuel is ignited. The fuel and air mixture is prepared during the intake and compression strokes, and the explosion happens during the power stroke. The ignition system is connected to the spark plugs and produces the high voltage needed to create the spark. The exhaust system is connected to the exhaust manifold, which collects the exhaust gases from each cylinder. It then routes the gases through a series of pipes and filters before releasing them outside of the vehicle. The spark occurs at the right time during the power stroke, ensuring that the fuel is ignited efficiently. That force is what is harnessed to generate power, and this process happens over and over again in each cylinder. One way is to use a turbocharger, which is a device that uses exhaust gases to increase the power output of the engine. One major issue is that they produce a lot of greenhouse gases, which contribute to climate change. Well, as I mentioned earlier, most vehicles use internal combustion engines. But there are other types of engines that are used in different applications. But no matter what type of engine is used, it's important to remember that they all convert one form of energy into another. Whether it's chemical energy into mechanical energy or electrical energy into kinetic energy. Understanding the basic principles of engines can help us appreciate the complexity and ingenuity that goes into powering the machines that we rely on every day. For example, electric motors are becoming more popular in vehicles as they provide a way to reduce emissions and improve energy efficiency. Steam engines, which were once widely used, are now mostly found in museums. And jet engines are used in aircraft to generate thrust. Additionally, they're not very energy efficient. A significant amount of the fuel that's burned is lost as waste heat. Despite these drawbacks, internal combustion engines are still the most common type of engine used in vehicles today. If you want to learn more about engines or other topics in mechanics, don't hesitate to reach out to us. Thanks for watching. A turbocharger is connected to the engine's exhaust system, and it uses the energy in the exhaust gases to spin a turbine, which in turn drives a compressor. The compressor then forces more air into the engine, which allows for more fuel to be burned and more power to be produced, and fuel to enter the cylinder during the intake stroke and push out the exhaust gases during the exhaust stroke. The lubrication system uses oil to lubricate the engine components, reducing wear and tear and helping to ensure that the engine runs smoothly. The oil is circulated throughout the engine by a pump and filter, and it's important to keep the engine properly lubricated to prevent damage. By cooling the air, an intercooler helps to increase the density of the air, which allows for more oxygen to be available for combustion. First off, internal combustion engines are incredibly powerful. They can generate a lot of torque and horsepower, which makes them ideal for powering heavy machinery and vehicles. Secondly, they're relatively simple and easy to manufacture. This means that they're cost-effective to produce, which keeps the cost of powered vehicles down. Additionally, internal combustion engines have been around for a long time, and there is a lot of infrastructure in place to support them. This includes things like gas stations and repair shops. This can result in increased horsepower and torque, as well as improved fuel economy. There are different types of fuel injection systems, but they all work to meter out the right amount of fuel for each cylinder. The fuel is injected into the cylinder during the intake stroke, where it mixes with air before being compressed and ignited. The valves are controlled by a camshaft, which is driven by the crankshaft. Now we also have the spark plug, which is responsible for igniting the fuel and air mixture. It's connected to the ignition system, which provides the high voltage needed to create the spark. We also have the connecting rod, which is a component that connects the piston to the crankshaft. As the piston moves up and down, it moves the connecting rod, which in turn rotates the crankshaft. And finally, there's the camshaft, which is responsible for controlling the valves. It's driven by the crankshaft and has lobes that push on the valve stems, opening and closing them at the right times. Each of these explosions creates a power stroke that moves the crankshaft, which is connected to the vehicle's transmission. And this is what ultimately turns the wheels. In other words, an engine takes some kind of fuel and burns it in order to produce power. During this time, the piston moves down inside the cylinder, and a valve opens, allowing fresh air and fuel to enter the cylinder. The next is the compression stroke. As the piston moves back up, it compresses the air and fuel mixture, preparing it for ignition. Then comes the power stroke. A spark plug ignites the compressed fuel, causing an explosion that drives the piston back down. Finally, there's the exhaust stroke, where the piston moves back up again, pushing the burnt gases out of the cylinder through an open valve. And this cycle then repeats itself over and over again, creating continuous power. And this power is what allows us to do things like drive a car or operate heavy machinery. So now you might be wondering, great, but how does this process actually work? Here's where things start to get interesting. Most engines, including those used in cars, motorcycles, boats, and even airplanes, are what's known as an internal combustion engine, or ICE for short. The reason why most engines are this type is because they're relatively simple and efficient, which makes them ideal for powering vehicles. Now, the basic idea behind an internal combustion engine is pretty straightforward, but there are 4 strokes or movements that happen inside the engine before this process can take place. First is the intake stroke. Now, although this is a relatively simple process, there are obviously many moving parts involved, and it takes a lot of precision engineering to make sure everything works together smoothly. The first is the piston. This is a cylindrical component that moves up and down inside the cylinder. Next, we have the valves. These are openings in the cylinder head that allow air. And now we have the fuel injection system, which is responsible for delivering fuel to the cylinders. And then we have the ignition system, which is responsible for providing the spark that ignites the fuel. Next, we have the exhaust system, which is responsible for getting rid of the burnt gases after the power stroke. Finally, there's the lubrication system, which is responsible for reducing friction between the moving parts of the engine. Now, there are various ways to improve the efficiency and performance of an engine. Another way to improve engine performance is to use an intercooler, which is a device that uses liquid to cool the air before it enters the cylinders. And now let's talk about the benefits of using an internal combustion engine. However, there are also some drawbacks to using internal combustion engines. Right, so now that you know how an engine works, what are some of the different types of engines out there?